MDP Group 17 is a team with diversity. Every member in the team has a unique ability and unique personality. So trying to bring all of them to work to accomplish our one goal in this project, that is to complete the challenge run, is difficult. Worse still, also as a member of the Arduino team, I have to spend most of my time on the actual arena to test the robot. Therefore, it requires a lot of effort to balance between my communication with the software team as well as making the hardware work. And I tell you, the robot is never as easy to make as you think it is.
For the Arduino team, actually it was a kind of sad story. If we tune the robot to go straight in the day, and the other morning it will went totally different. So we spent weeks in tuning the parameters to let it go straight. But although with all these difficulties, we still never give up trying.
In order to compensate for the not so perfect hardware, we need functions to control the robot. For instance, in order to let the robot move straight, we need a PID control. And there's also an adaptive calibration that we came up with in order to compensate for the issue that the PID doesn't start immediately when the robot moves. Also, as the robot travels through the maze, there will be errors that accumulate throughout time. So we need the robot to align itself for distance and as well as angle.
However, making the robot works as expected is only part of the equation. So the software is equally as important as the hardware.
This algorithm is actually original and is created by us only.
Our first algorithm that we have used is the right wall hugging algorithm. So this right wall hugging algorithm will bring the robot from the start zone to the end zone, hugging the right wall. So at all times, the robot will be sticking to its right wall all the way from the start zone to the end zone and back to the start zone again. So our second algorithm is the remaining exploration algorithm, where it will look for an unexplored grid and it will search the 4 locations beside the unexplored grid to try to explore that grid.
Our core framework can be used on any platform: the PC, the Raspberry Pi, and the Android tablet. The software is a complete of various layers and modules, and each module entirely depends on the abstractions. By implementing this design, we can optimize the implementation for each single platform separately while maintaining a uniform architecture and maximizing the reuse of source code.
The Android development phase, we have faced many doubts and many challenges, but despite that, we pushed on and never gave up.
Okay, so basically this is the Android app developed by the Android team. So how this whole process starts off for an Android app is basically keying initial values for the robot location and the robot direction. Moving on, we will just hit on the explore button. The MDF strings will also be subsequently generated on the go for the Android app.
As you can see, a light blue path will show the fastest path.
Raspberry Pi is in the center of the whole system. Normally, other groups, they use C or Python as the programming language for Raspberry Pi. But for us, we use Java. It makes the whole system consistent. We use Java for the API, for the algorithm on PC, and of course, for the Android device. It's really changing for us.
The challenge is 1, 2, start.